Hey Claire, I'm in my living room. I'm going to try to explain this to you on the paper. So, your problem has a lot of information that you don't actually need. So, for you to understand the question, you have to know a couple of things. They might have explained it to you. I don't know how to do this. I've never done this before on camera. Okay. So, if you have a cylinder of water, there's my cylinder. Here's the water level. You're saying it's 36.0 mLs in this 100 ml cylinder. So that's a little extra information they're giving you is the 100 mLs. You don't really need to know how big the cylinder is. You just need to know what is the current volume level on the cylinder. So that's 36 mLs. If you're going to put something in the water, whatever it is, it's going to what they call displace the water. So if you put this cube into the water, it's going to displace the water. So it's going to move the water level up. Just like if you had a cube in here and you were to take it out, your water level would go down. Because when it's in here, it's taking up space. Okay, so that's what volume is. Volume is space. Volume equals space. And it's really hard to look through my camera and write out the paper at the same time. Okay. So, when you put this cube into the water, it will displace the water level, the amount of volume that the cube is. So you have to find out what the volume of the cube is. When you're measuring a liquid, volume is usually measured in milliliters. When you're measuring the volume of a solid, it's usually measured in cubic centimeters. So we're trying to find out what the cubic centimeters is of this cube. And it tells you that in the problem. It tells you that each side, both length, height, and width, is 2.3 centimeters. So to get the volume, you're just going to multiply each side, the length, the height, and the width. So they're all equal. They could be different numbers. I mean, you can have different shape cylinders, some tall, etc. Tall ones. So obviously here you see the height is much bigger, so that number would be different. You can have deep, like really deep cubes or really short cubes. So anyway, so here you're doing 2.3, I don't know if you can see that, centimeters times 2.3 centimeters times 2.3 centimeters. That's going to equal 12 point, and I think it's like 167. I don't know if you guys are doing significant figures yet, but if you were, then your answer would be 12.2 because you're rounding to your most significant figure, which would be the first decimal point here, 12.2 centimeters cubed. That is actually equals your volume of your cube. So you have the answer right there. So when you put this cube that has a volume of 12.2 centimeters cubed into the water, it's going to displace it by 12.2 centimeters cubed. Now, the other thing you have to know is that 1 ml, I'm so messy, hold on, 1 ml equals 1 cubic centimeter. So, right? If you can, so it's a 1-to-1 ratio, cubic centimeters to mLs. So, you know that this cube is going to displace that water by 12.2 milliliters. So, you're going to do 36.0 mLs plus 12.2 12.2 mLs. Now you really have to show all this work a little bit more step by step on your paper. Teachers tend to like that. They like to see that you're thinking through the problem, and even if you have the wrong answer, the way you got to the answer might be correct, but maybe you just had an arithmetic issue, and they'll still give you points for that. So I would always do like step by step. Anyway, so what does this equal? This equals, let me try to do the math in my head, 8.4 mLs. Always keep track of your units. So in other words, whether this could be mLs, centimeters cube, you always want to indicate, okay, what are you talking about? 12.2 what? 12.2 meters, 12.2 bananas, 12.2 what? So always indicate your unit. So your answer would be, the new level would be 48.2 mLs. I hope that helped. Let me know if you have any questions, and I'll try to answer them as best I can. All right, good luck. Hope that helps.